All right, Math 126 students, here we go again. Volumes, volumes, and more volumes. Okay, find the z's. Z equals the square root of 6 plus x squared plus y squared. There's actually a plus or minus. Now, the moment it says hyperboloid, this is one I might want to visualize at the beginning. Remember, we had a hyperboloid of one sheet, and we had a hyperboloid of two sheets. And really, when I read the question, so there's a little bit of visualization. You could wait on this, but ultimately you have these two things. This is a hyperboloid of two sheets. There's the upper hyperboloid, and there's the lower. Okay, at some point we'll have to think about that, but we could still move forward even if we were stuck. Then we draw the region. We draw any given x and y bounds. What are the given x and y bounds? They didn't give me any. So then what do? I find when the surfaces intersect. When do the surfaces intersect? And notice, since it's a positive z, I already know I'm only talking about the upper one. That's the part that scares students, but I'm trying to see how far we can go before we're worried about that. Minus y squared plus 9 equals 6. Let's rearrange this. You get 3 is equal to x squared plus y squared, and we have it. That's where they meet. And so I'm integrating above that. And I'm almost done. So the comment I should have already made was the integrands are these. There's actually two surfaces. I should have said this already. I'm getting out of order, too excited. 6 plus x squared plus y squared. That's one thing we need to compute. And another thing we need to compute, let me just erase this so I can fit it in. Sorry to do that. Is the double integral. And I talked in class how you could just compute those separately, and whichever one is bigger, subtract the smaller one from it, because we're trying to find the volume between them. And I'll show you some visuals in a second, but we're trying to do this without the visuals. A few students have said, but I really want to know which one's on top. So there's an easy way to do that without visualizing. Again, it's great to visualize as well. I'm just trying to give you some tips for those that are worried about this. Pick a random point in there. How about 0, 0? If I plug in 0, 0 here, you get the square root of 6. Is the square root of 6 bigger or smaller than 3? If you don't know that, then you fail. No, just joking. It's 3 is the square root of 9. So 3 is bigger. So that tells me ahead of time, this will be bigger. But I made the point in class that even if you were stuck, you can what's nice about all of this is we can proceed no matter what. So I'm going to do it in polar, 0 to 2 pi, 0 to root 3. All right. And then I'm going to do, let's see, we said that 3 is bigger. So 3 already theta. And then I'm going to subtract the double integral, 0 to 2 pi, 0 to root 3, square root of 6 plus r squared, already theta. Compute, done. So if you want to see some visuals, we're not talking about the negative because this plane, this z equals 3, let me type it in here as I go, z equals 3, just goes on, is there. It doesn't touch the bottom one. It's in between those two. So it doesn't, there's nothing going on with the negative. It's this little bowl, whatever that is. Okay, so we're confining the volume of that bowl. Let me make it so we can actually see it quickly. Here we go. There it is. I'm going to restrict the surface. I'm going to get rid of the bottom. I don't need that. I'm going to get rid of the surface, and I'm just going to... So here's the region on the ground. Yay. We're finding the volume between that and that, which is actually a cylinder. Like this first volume I could have done without calculus. It's just 3 times the area of the region on the ground, so it's 3 times pi times square root of 3 squared. So that's what you're going to get out of this. It's that cylinder. If you're having trouble visualizing, it's that cylinder. And then separately, I want the volume under the surface. And so it's going to be a pretty small volume because we're finding the volume above the ground and below the hyperboloid, and above the ground and below the cylinder, below the plane, and subtracting. All right, hope that helps.